Basics of remote sensing and GIS. Remote sensing is the process of collecting data about objects or landscape features without coming into direct physical contact with them. It can be anything from visual assessment of one's surrounding area, using a handheld camera, aerial photography, satellite imagery. A satellite can be defined as any object, either man-made or naturally occurring, that orbits around something else. For example, the Moon orbits around Earth and is thus a satellite. The Earth orbits around the Sun and is a satellite of the Sun. In today's context, we reserve the term remote sensing to imagery collected by electro-optical sensors. In other words, instruments which measure electromagnetic radiation EMR that is reflected or emitted from the terrain radiant energy. Scanners that record the amount of reflected light energy of the Sun from the Earth's surfaces. This energy is recorded within certain segments of the electromagnetic spectrum. Every entity on the face of the Earth has unique and varying energy levels, and remote sensing systems simply measure these different levels. These energy levels are portrayed by way of the electromagnetic spectrum. The M spectrum measures energy from gamma rays to radio waves. Types of orbits: 1. Low Earth orbit. 2. Polar orbit. 3. Geostationary orbit. 4. Elliptical orbit. Low Earth orbit. When a satellite circles close to Earth, we say it's in low Earth orbit. Satellites in LEO are just 200–500 miles high. They can circle Earth in about 90 minutes. Polar orbit. The polar orbit is a particular type of low Earth orbit. The only difference is that a satellite in polar orbit travels the north-south direction, rather than the more common east-west direction. The geosynchronous orbit can also be called a geostationary orbit. A satellite in Geoshkanav's equatorial orbit Geo is located exactly 22,300 miles out in space. Many communications satellites travel in geosynchronous orbits, including those that relay TV signals into our homes. Elliptical orbit. A satellite in elliptical orbit follows an oval-shaped path. One part of the orbit is closest to the center of Earth's perigee and the other part is farthest away. Communications satellites in elliptical orbits cover the areas in the high northern and southern hemispheres that are not covered by geosatellites. These are the different types of sensors. 1 is active sensor. Second one is passive sensor. Remote sensing systems which measure energy that is naturally available are called passive sensors. Passive sensors can only be used to detect energy when the naturally occurring energy is available. For all reflected energy, this can only take place during the time when the Sun is illuminating the Earth. Active sensors, on the other hand, provide their own energy source for illumination. The sensor emits radiation which is directed toward the target to be investigated. The radiation reflected from that target is detected and measured by the sensor. process involved in remote sensing 1 energy source to sunrays and atmosphere 3 sunrays and objects on the Earth for recording of energy by the sensor 5 transmission, reception, and processing 6 interpretation and analysis 7 application. Image resolution 1. Spatial resolution 2. Spectral resolution 3. Radiometric resolution 4. Temporal resolution. Spatial resolution refers to the size of the smallest possible feature that can be detected. Spectral resolution, defined by the portions of the EM spectrum the sensor is designed to record number of spectral bands and the spectral range of the bandwidth. Radiometric resolution, the number of gray levels that can be differentiated by a sensor. The radiometric resolution of an imaging system describes its ability to discriminate very slight differences in energy. The finer the radiometric resolution of a sensor, the more sensitive it is to detecting small differences in reflected or emitted energy. Temporal resolution refers to the repeat cycle of the censored platform and the length of time in service. Across-track scanners scan the Earth in a series of lines. The lines are oriented perpendicular to the direction of motion of the censored platform, i.e. across the swath. Along-track scanners also use the forward motion of the platform to record successive scan lines and build up a two-dimensional image, perpendicular to the flight direction. The applications of remote sensing area is very large. Some of the application areas are represented here: agriculture, forest, soil, water resources, land use and land cover, environment, ocean applications, disaster warning and management.